Alrighty, folks, this is me solving the number 9 from the review that we didn't finish in class today. Sodium reacts with water given the following reaction there. Notice it reacts completely, meaning that the sodium is the limiting reactant. It goes to completion. In other words, there's more than enough water there to react, so you have to worry about limiting reactant at all. And you have to figure out the concentration at the end, so you have to figure out the amount of sodium hydroxide because you want the resulting concentration of sodium hydroxide. And don't forget that concentration is moles divided by volume. So I need moles and I need the volume. The volume I already have, of course. So I just need to figure out how many moles of sodium hydroxide are going to be made. I have 1.5 grams of sodium. I want to figure out how many moles of sodium hydroxide I'm going to make. You'll notice it's a 1-to-1 ratio or a 2-to-2 ratio, same thing. So once you find moles of sodium, that is going to be the same as the moles of sodium hydroxide. Okay, and so once you have moles of sodium hydroxide, you're just going to divide by 250. I guess to be fair, we should say 2 or 0.25 cubic decimeters, and that'll equal the concentration of sodium hydroxide. Okay, so here we go with the calculation. Starting with sodium, and then convert it to moles by dividing by the molecular mass. 0.0500 moles to 3 sig figs. And again, that equals the number of moles of sodium hydroxide. Okay, so I'm not showing that normal step where I multiply by the mole ratio, but because it's a 1-to-1 ratio, I could show it, I just don't need to. And then I'm just going to divide then by 0.25 liters, and that is going to give me, or cubic decimeters, same thing, and that'll give me my answer. And I guess to be fair, it should be only 2 sig figs, seeing as they give you 250 milliliters as a volume, not 2.50 times 10 to the power of 2. So 2 sig figs I think is the best, but you probably get away with 2 or 3 there with that one. Okay, there you go. Let's move on to the next question. Okay, number 10, we're going to find the limiting reactant for this reaction here. And so we'll convert to moles, divide by the coefficients. Here we go. Careful that you convert the kilograms to grams. Divide by molecular mass, and divide by the coefficient. And do the same thing for the Cu2S, the copper 1 sulfide. And clearly the copper 1 sulfide is limiting reactant because that is the smaller number. On to part B. First thing to note is the mole ratio between copper and copper 1 oxide. Oh sorry, I want the other one, Cu2S. 1 second. Meant to do that. Okay, and it's a 6-to-1 ratio. So for every mole of Cu2S that reacts, 6 moles of copper will be produced. I already have the moles of copper 1 sulfide right there. So I don't need to do that calculation again for the sake of IB. So all I'm going to do is just take that molar amount, this is in moles, okay, and multiply by the mole ratio for the next part. Okay, just like that. And obviously my units cancel out there, and I get a certain amount of moles of Cu, and I just multiply by the molar mass of Cu, and cross out units there as well. And I'm left with grams of Cu, and the correct answer you get then is about 12 kilograms. And whatever the sig fig should be for that, let me just check real quick. Looks like 3 sig figs, so there you go, 12.0 kilograms. You could also say, 12,000 grams. That works as well. Okay, and there you go. I think that is it. So consider yourself helped. If you have any problems or want more answers to various questions, likes problems, whatever, you know where to find me. Have a great night, everybody.